Linear programming sounds complicated. This is where we are trying to get our equations to tell us things about the business that we're running, or how to minimize or maximize profits, or minimize or maximize an item like profits. So let's look at this. We have a screen printing business, and we have t-shirts and sweatshirts. We need to figure out how much we can get done with our supplies constraints, but we also want to make the most profit. And so we are going to come up with a couple of equations. We have no more than 20 hours to make the shirts. So 20 hours is times 60 gives us our minutes, which is 120 minutes, because we're going to go ahead and go down to minutes because it helps easier to work with these problems. For this problem, if you want to spend no more than $600 in supplies, and you need to have at least 50 shirts or items to sell. And we want to know how many t-shirts we should sell and sweatshirts to maximize our profit and what that profit would be. So one colored t-shirt takes 10 minutes to make. It costs us $4 a t-shirt, and its profit is $6 a t-shirt. The 3 colored t-shirts, the cost is $20, but we make a $20 profit. And it takes about 30 minutes to make. And the reason I went to minutes before is because we know our shirt times and sweatshirt times in minutes. And so first thing we're going to do is we're going to come up with several different equations or inequalities to help us come up with our lines that we started off with the linear systems of linear inequalities. This is very similar to what we did yesterday and day before with the system of linear inequalities. To me, it's easier when working with a word problem like this to create it into a table like this. My minutes I'm going to use is the equation I'm going to create first, and I am going to use X for t-shirts and Y for sweatshirts. I just chose one letter for one and one letter for the other. So, and how long it takes me to make it. It says my t-shirt is 10 minutes, so 10X. My sweatshirt, it says it takes 30 minutes, so 30Y. And we want it to be at most 1,200 minutes to get done, because that's how much time we have to work on it to get it done. So if we want it at most, that means we need less than or equal to. And when we combine these to write our equation, we're just going to put a plus sign in between it, because we would combine our minutes from how long it took us to make the t-shirts and how long it took us to make our sweatshirts. So now let's look at the number. We want to have at least 50 items to sell. So however many sweatshirts we make, or t-shirts we make, plus however many sweatshirts we make, has to be more than 50 or at least 50, so that's more than or equal to. Now the cost, when I look at my t-shirt, it tells me my supply cost is $4. So it's going to cost me $4 for every t-shirt I make. And my supply cost for the sweatshirt is $20. Again, I'm going to add them together. And we have a limited supply budget. We only have $600. So we have to be no more than $600 on our supplies. The last equation we're going to come up with is going to be our profit equation. This equation is actually not going to be graphed. We're going to use that equation at the end to compare and find out what is the most profit. And so it tells me I make $6 profit on every t-shirt and $20 profit on every sweatshirt. And there is no equal to besides the equation itself, so 6x plus 20y. We're going to come up with that value on each one of these. But those are not the only constraints we have. We also have the constraint of the fact that we can't have negative number of t-shirts sold. So that must be greater than or equal to 0. And the same thing on the sweatshirts. It must be greater than or equal to 0. And so we are going to graph 1, 2, 3, 4, 5 equations on the same graph. And we are going to shade and figure out where the overlap section is between those 5 inequalities. But I cannot graph it from this step. I need to get it solved for y. So let's go ahead and do this first equation where we solve it for y. So I'm going to move my 10x over to the other side, leaving me 30. Y is less than or equal to negative 10x plus 1200. Divide by 30 to each term. Because 30 is positive, I don't have to flip my inequality symbol. That gives me negative 1/3 x plus 40. So my y-intercept is 0, 40, and my slope is a negative 1/3. And so when I graph that, it looks like this. I graphed my 40 of my y-intercept. I went down 1 over 3, down 1 over 3. And as long as your counting value for your x and y are the same, it doesn't matter if it is down 10 over 30, because that reduces to the same values. And I want it to be less than that, so when I shade this line, I want to shade going this way. So let's take our second inequality that we came up with. This one's a little bit easier to get isolated. We're going to move our x over. And so y is greater than or equal to negative x plus 50. And so, again, this line we were shaded below. The blue line is our new line. I had a y-intercept of 50, and then from there I went down 1 over 1 and plotted those points. This one had greater than, so this one, the blue line, I'm going to shade above. So right now, if I was just to shade it now, it would be this section here. But we still have 3 more inequalities to add. The next equation we have, or inequality we have, is 4x plus 20y is less than or equal to 600. So I need to move the 4x over. 20y is less than or equal to negative 4x plus 600. Divide by 20. And y is less than or equal to negative 1/5 x plus 30. And I graphed that equation in green. So I started off at the 30, down 1 over 5. Just by my tick marks, that's what it would show up as. And so, again, just kind of reminding ourselves of what we had shaded. Y'all's will actually, if you draw these arrows in, will stay in there. I just have to keep drawing them back in. So now, if we're less than that line, so that means we need to be below the green line as well. So now our area that's shaded has been made a little bit smaller. It's just this little piece here. The last 2 things we have to graph are the x is greater than or equal to 0 and the y is greater than or equal to 0. And so the x is greater than or equal to 0 is there, and here's the y is greater than or equal to 0. So now we have all 5 graphed. So we had this area here that is our constraint. The next thing that's different from, this is the step where it starts getting a little different than yesterday. We need to identify the vertices that make the polygon of that shaded region. And so each one of these, my tick marks are counting by 5s. So that would be this first one on the blue and green meeting up is going to be at 25, 25. The blue and orange meeting up is going to happen at 50, 0. And all I'm doing is coming up with the ordered pair by reading it off of the chart. The orange and red line is going to be at 120, 0. And the red and green lines are going to be at 75, 0. Or 15. We are now going to use that last equation. Now that we have these 4 vertices, we're going to take them into that profit equation, which was that 6x plus 20y. And we're going to find out which one of these gives us the most amount of profit. And so we're going to take each of those 4 order pairs that we got from the graph that I highlighted in purple, and we're just going to do them one at a time into that profit equation that we created on that first page. So that says 6 times my x, which in the first one is 25, plus 20 times my y, which is 25, is equal to my profit. And so when I type that in the calculator, I come up with a profit of $650. On the next one, I do 6 times 50, because that's their x value, plus 20 times 0. And 6 times 50 is 300. And then we're going to do the next one, where we're going to do 6 times 75 plus 20 times 15. And we find out that value. And when we find that value, it is $750. And then our last one is 6 times 120 plus 20 times 0. And that's going to give us 720. So now we look at our profits, and we want to maximize our profits. So we're looking for the profit that is the greatest, and that is in this scenario. So what that means is if we sell 75 t-shirts and 15 sweatshirts, we can make a profit of $750, and that is our max profit. So that's our goal, to have the best profit we can have in this scenario, is to sell 75 t-shirts and 15 sweatshirts. That means when we go to this blues festival, we want to bring 75 t-shirts and 15 sweatshirts in order to maximize my profit for that weekend.